Well, hi there. Today we're going to talk a little bit about rounding whole numbers, rounding mixed numbers, and estimating answers. Now, the truth is that rounded numbers are often used instead of exact numbers when we estimate. When we go to the grocery store and we're trying to figure out how much money we're going to spend, oftentimes we will round the total of something up so that we have enough extra money to pay for it. We use it in math quite a bit when we're trying to do measurements and so on. It is only used when we don't have to be absolutely perfect. Now, there are a couple really good ways to round. One way, not as practical maybe as others, but is to use a number line. Plot the number on a number line to decide which way to round it. Okay, so let's say we wanted to round 66 to the nearest 10. We could plot 60, 65, and 70 on a number line, and then go ahead and put the number 66 on that number line, and then look at it and say to ourselves, is 66 closer to 60 or 70? If it's closer to 70, which it happens to be, then we would round it up to 70 because we're rounding to the nearest 10. The basic idea is to see what number is it closest to so that we can round it. Okay, so ways to round continued. Place value rounding, that's another way to round. Okay, place value is when you're given a specific place value that the number is to be rounded to, and then you look to the right of that base value to see if it's a 5 or larger. So first we must know which decimal place we are rounding to. Find the decimal place and look to the right to determine whether we change the number up or do we leave it the same. And that's important because we don't, if the number is less than 5, we don't change the number, we just kind of chop it off and put zeros where the other place values were. Rounding up or down depends on whether the value to the right of the place value we are rounding to is 5 or greater. This is called the 4-5 split. If it's 5 or greater, we will round up. If it is less than 5, it doesn't change. However, we do lop off, or I say cut off, any numbers after the place value we are rounding. Now that's when we're talking about decimals. If we're talking about a number that's like, let's say 2,190, and we are rounding to the nearest 1,000, this is our place value, this is the number we look at, it is not 5 or greater, so then rounded it would just be 2,000. So in the case of a larger number, not a decimal, we do have to fill the places in with zeros. Okay? Now we're going to do just a couple of examples just to see if you remember how to round. So here we go. Round 76.829 to the nearest tenth. First of all, we have to figure out what's the nearest tenth. Well, in this case, tenth is here, and show it here. The number that we're rounding would be the 8 if we're going to round it. The number we look to is the number to its right, which is the 2. Okay, so we look at the 2. The number we look at to decide this is less than 5, so the 8 won't change. And this is the place value. So when we look at it this way, since this is a 2, this 8 won't change. This is the new rounded value. Notice there's nothing behind the 8. There's nothing after it. We lopped those off when we rounded to the 10th spot. There will be nothing after that 8. If we'd have rounded to the hundredths place, then the number would have ended there. Okay? If we'd have rounded to the ones place, then the number would have ended there. And in fact, that would have ended up being 77. Okay, we're rounding to the nearest 1,000. So this is the thousands place right here. The number to the right is a 5. It is 5 or larger. So we are going to round up. And instead of 67,000, it's going to be 68,000. Notice the 3 placeholder zeros. Okay, the 593.28 all goes away, and we just round to the place value. I hope that makes sense to everyone. Okay? Now, we can round fractions too. What if we were to round a fraction to the next whole number? Okay, there's a couple ways to look at this. First of all, we look at the fractional part of the mixed number. We really don't have to look at the whole number part right away. We just want to look at the fractional part. If it is closer to 0, then the answer just becomes the whole number. If it is closer to 1, the fraction that is, then the answer we would round up, and that would become, the whole number would become larger. Okay? In this case, 7 over 12 is closer to 1, so we would round to 6. Now, I've had it said to me that when we're looking at these numbers, and notice this is 7 over 12. If you can't decide in your mind, is 7 over 12 closer to 1, or is it less than, is it going to be on the other side, so that you don't, we always look at the denominator, okay? Take half of the denominator, which in this case happens to be 6, okay? And then look at it and go, is 7 bigger than 6, or is 7 less than 6? In this case, 7 is bigger than 6, so this number is going to be closer to 1. It's bigger because it's more than half. 6 twelfths would have been half. 7 twelfths is bigger than half. So that's one way to look at it. Okay? It might be helpful to you, it might not, but I've had quite a few of my students have said, yeah, that's the way we do it all the time. So we're going to practice just a little bit. 3 1/3. We look at 1/3. It is not closer to 1, so we're going to leave it as 3. 4 4/5. 4/5 is closer to 1, so we would move it up to 5. 6 4/9. 4/9, now if you're kind of iffy about this, okay, I don't know about 4/9, go over here and go, okay, half of 9 would be 4.5. Is 4 bigger than 4.5 or less than 4.5? It is less than 4.5, so this 6 is going to stay and it's going to round to 6. Okay? 8 11/22. In this case, you might recognize that 11/22 is 1/2, and that's 0.5, so it would make it 0.5 would be 5 or more, so it's going to make it round up. So instead of staying at 8, it's going to go to 9. And that's kind of a little bit of practice. Okay? This follows through when we are estimating, especially when you don't need when you need a quick answer and don't need absolute accuracy. You will estimate. Okay? So, for instance, 2 1/3 times 3 3/4, we would decide, is that 2 1/3, is that going to just stay 2, or is it going to go to 3? Well, 1/3 is closer to 1, so that's going to stay at 2. And at 3 3/4 here, well, 3/4, half of 4 would be 2. So 3 is definitely bigger than 2, and if you know 3/4 is often referred to as like 75% or 75 over 100, so it's definitely closer to 1. So this is going to round to 4, and 2 times 4 is 8. We just move these over here and go 2 times 4. Now, remember, this is an estimate. It is not an absolute accurate amount. It's an estimate. Here's another one. Ooh, big number, okay? 3,916 times 412. Okay? First of all, 3,916, if we're rounding just to the whole numbers, this is going to be rounding to 4,000. Okay? This 412, definitely not going to go to 500. It's going to stay at 400. So we rewrite it over here. We end up with 4,000 times 400. 4 times 4 is 16. And we have 1, 2, 3, 4, 5 zeros. So we end up with 1,600,000. Always ask yourself a question. Is this closer to 3,000 or 4,000? Is this closer to 400 or 500? That will help you. Okay? All right. Now, rounding just a little bit of practice. Round 1,870 to the nearest 100. Here's your 100 spot. This is the number you're looking at, definitely larger than 5, so it rounds to 1,900. Here's another one. Round 6,321 to the nearest thousand. Okay, here's your thousand spot. Here's the number you're looking at. That 3 is not larger than 5. Therefore, it's going to round to 6,000 because this number is not 5 or greater. Okay, now we're going to do a multiplication problem. 321 times 97. Is 321 closer to 300 or is it closer to 400? Yep, it's closer to 300. Is 97 closer to nothing or is it closer to 100? In this case, of course, it went to 100. And you ended up with 300 times 100. 3 times 1 is 3. You got 4 zeros. So you end up with 30,000. Okay? One last one I want to look at here. 7209 minus 543. Is 7209 closer to 7,000 or 8,000? And you would have to say 7,000, yeah. And is 543 closer to 500 or 600? And it's closer to 500. This is a subtraction problem. So 7,000 minus 500 gives you 6,500. Okay, one last page that I want to go over here. I hadn't done any division, so I kind of wanted to throw a division problem in for you. 1823 divided by 597. 1823, is it closer to 1800 or 1900? Closer to 18. 597, is it closer to 500 or 600? It is closer to 600. So we end up with 1800 divided by 600. 18 divided by 6 is 3. And if you check your math and go ahead, you could set it up this way too and get rid of those zeros, and you end up with 18 over 6, which of course is 3, and that works very well. One last thing, and this is an application which is kind of cool. I think maybe I'm going to cover this part on the right up for just a second because I want to go through this part on the left. Okay, so what I want to show you is we want to multiply. Well, we want to find the area of the figure, okay? And I definitely would draw this on your paper. It doesn't have to be to scale, of course, or anything, but make sure that you label it. And area has to be length times width. But we just kind of want to estimate it. So we don't want to make it real hard for ourselves. So 4 1/8 is the length. Here's the length, and here's the width. And 3 7/8 is the width. To get area, you take length times width. So 4 1/8 times 3 7/8. That sounds kind of hard. So let's estimate by rounding. 4 1/8, closer to 4, closer to 5. Closer to 4, very good. Okay, so we're going to make the length 4. Width, 3 7/8. Is 3 7/8 closer to 3? Or is 3 7/8 closer to 4? Yeah, it's closer to 4. So look at there. Actually, what we end up figuring is something that's almost a square. It seems like we're using the dimensions of a square, but we're not. We're going to go ahead and do the math, and 4 times 4 is 16 square inches. Now, I went ahead and did the math with the actual measurements, and you'd be surprised what I found out. Here's the interesting fact. If I take 4 1/8 times 3 7/8, I put them as improper fractions, and I actually do the math and multiply. 33 times 31 is 1,023, and yes, I did use a calculator for that. And 8 times 8 was 64, and no, I didn't use a calculator for that. Do the division, okay? And that probably you would want to do on a calculator because it is pretty long. And guess what I got for an answer? I got 15.984375, which would round to 16. Isn't that what we got down here when we estimated? So is estimation a good thing to use? You betcha. This would have been kind of hard for us to figure out. It's kind of nice to be able to estimate once in a while, but remember, only use estimation when you're told to. Don't just use it as a matter of fact, because you will get the problem wrong if they're asking for exact answers. Have a great day, and I hope you enjoyed this video.